Hi, this is Victor and welcome back to my math tutoring channel. In this video, as I promised you before, I will show you the strategy to be used to find the right test to determine if a series converge or diverge. And let's not waste a lot of time. Let's start by the strategy number one. So strategy number one, very briefly, check if the series n equal 1 to infinity of an is different than 0, or if the limit of when n goes to infinity of an is different than 0. If that is the case, we use the divergent test, and I will explain the divergent test too later in this video. Divergence test. But if it does not go, if the sum of n equal 1 to infinity of an is equal to 0, and if the limit of an when n goes to infinity of an is equal to 0, then we cannot conclude anything. We need more information, and we will see the more information in the next strategy. I will give you a strategy how to find the convergence of a series. So let's go to strategy number 2. In strategy number 2, we'll talk about the P series and the geometric series. The P series, sometimes we call it the Riemann series. So, if the series is a P series, because there is another strategy, if the series is similar to P series and similar to geometric series. But on this one, if a series is a P series, or Riemann series, it's the same thing, or if it is a geometric series. The P series, let's take out the or from here, resemble to sum of 1 over n to the power of p. And the geometric series resemble to that. Sum for n equal 1 to infinity of a times r to the power of n, or sum n equal 1 to infinity, sorry, this is 0 here, 0 to infinity, this is 1 to infinity of a r to the power n minus 1. So for those two series, the P series will converge. P series will converge if P is greater than 1. That's easy. Now the geometric series will converge toward A divided by 1 minus R if the absolute value of R is less than 1. And in my previous video, we said A is the first number of the series, first element of the series, and R is the ratio, and R is equal an plus 1 divided by an. That's the ratio. So if the absolute value of R is less than 1, so my geometric series, this is geometric here, it will converge toward A, which is the first term, divided by 1 minus R. And we will see some example on that later on. So let's talk about the third strategy. In the second one, I said if a series is a P series or a geometric series. In the third, if a series is similar, to a P series or geometric series. So in that case, we do the limit comparison test or the comparison test. So what are those tests? Limit comparison test or the comparison test. So the limit comparison test, if we take sum of n equal 1 to infinity of an and another series sum of n equal 1 to infinity of bn, an should be greater or equal to than 0 and bn, an greater or equal, and bn should be greater than 0 here. For all n, for any n that is positive, only an can be 0 and bn should be like any positive number. If the limit of an divided by bn when n goes to infinity is equal to a constant, and that constant is constant, it's between 0 and less than infinity, then if bn diverge, an diverge, and if bn converge, an converge. We will do example after and you will see what I mean. And the comparison test, we did something like that in my previous video that I will put the link in this one to the previous video, comparison test. Let's say if we have a series of 5n plus 5 and n equal 1 to infinity. So if n goes to infinity, 5 times infinity is infinity, plus 5, it's still infinity. So the 5 here is insignificant. So I can compare it to series n equal 1 to infinity of 5n. So if 5n converge, then 5n plus 5 converge, and if the sum of 5n diverge, that series diverge. It's easier to compare it here, and I have an example that I put in my previous video, and I will reference it in the comment of that video down in the description of that video. Now the fourth strategy, the fourth one, if a series is a rational series. Rational, that means it's a fraction. If a series is a rational expression, that means it is a fraction. I have a fraction of polynomial or polynomial under a square, under a root. I use a fraction that contain only polynomial. Polynomial with an I, not a Y. Or polynomial under a root. For that kind of theory, we do the comparison or the limit comparison test. We do, as seen before. We do the comparison or limit comparison. But we have to be careful in order to what I said is true. All the terms of the series need to be positive. All terms need to be positive. That means if I have, let's say, 2x squared plus 3x plus 4x4, I don't have any negative in my polynomial. All the terms need to be positive, then I can, and the series is a rational expression, like a fraction. We do the comparison or the limit comparison test. Let's go to strategy number 5. If a series contains a factorial, that mean, like 3 factorial is equal 3 times 2 times 1 or 4 factorial equal 4 times 3 times 2 times 1. So if it contain factorial, the only test that work is the ratio test. We do a ratio test. If it contain a constant, if it contain a constant like k to the power of n, then the ratio test may work too. Ratio test may work. We'll see examples. Strategy number 6, if a series has -1 to the power of n, if a series has -1 to the power of n an, or -1 to the power n plus 1 an, then the alternative test should work. You have to use alternative test. Alternative test. Let's do an example of alternative. Let's explain the alternative test. If we have a sum of an with then the limit of when n goes to infinity of an plus 1 divided by an, which is the ratio, that's the ratio test. If the limit is less than 1, we say the series converge. If the limit is greater than 1, we say that the series diverge. And if the limit is equal to 1, the series can be divergent or conditional conversion or conditional conversion or absolutely conversion. We do some tests and you will see some example. Let's finish the strategy, and after that I will do a video with all the example that I used here. Let's say strategy number 7, if an equal f of n, if an equal f of n and f of n is positive and decreasing, it is positive and decreasing function, so we can write it as between a and as integral between a and infinity of f of x dx, and that would be easy to evaluate under the integral test. Like, let's explain it a little bit more. If I have a series sum of n equal to k to infinity of an, and then we see if integral of k to infinity of f of x dx converge, the an here is equal to f of n, and this is f of n here, sorry. And if the integral converge, then the series converge, then sum of n equal to k to infinity converge. So if an equal f of n, and if f of n is positive, we take the function integral of f of n or f of x dx or f of n dn, and if f of n dn converge, then that series converge. If it diverges, the series diverge. Let's do the last strategy before passing to a new video and with example on the series. So if the series term are like an equal bn to the power of n, then to the power of n, then we use the root test. So if we have sum of an we do the limit of square root to the nth root, not square root, nth root to absolute value of an is equal to the limit of, when n goes to infinity here, of absolute value of an to the power of 1 over n. If the limit is less than 1, if that limit less than 1, we say the series converge, and greater than 1 it diverge, and equal to 1 it can, like above, it can diverge or conditionally diverge or absolutely converge. My next video will be example of all what I gave you here, all the tests that all the strategy, and we will apply them. So if you like my video, please subscribe to my channel, and if you put a like, I would really appreciate it. Subscribing, it's like just click on the subscribe button below. They will not ask you neither you to log in or your password or your username. Just click on that button and you subscribe. Thank you very much.